Let's recall volumes and areas of some of the basic shapes that you need to learn in high school and the college. So let's start with the cube. So how to draw a cube? So we can draw a cube like this. So we draw like that and then go down, and then we have these sides, and then connect the sides, and then we draw one parallel and connect it. So that's how you draw a cube. And then let's say those sides are A and A and A, all three sides, because a cube. So then the volume is simply given by, because what we do, we're going to multiply the length, width and the height. So you're going to multiply the length, width and the height, and all three are the same. So you're going to get A cube as the volume. And then for the surface area, S means area, surface area. So surface area, and you can see one side is A squared, but there are 6 sides. So it is 6A squared, that is the surface area. So let's look at the next one. Next one is what we normally call the rectangular prism. So how to draw a rectangular prism? So first again, we can start with the smaller side like that. So this is smaller side. And then what we do, we can draw the long side like that, and then it's parallel. And then what you do, we draw a parallel line here and connect it. So that's how you draw a rectangular prism. And again, the length, we can assume, we just go with the normal values that we normally use in application. So we use the L for the length, and the width, which is little shorter, and the height. So those are the three. And then we can simplify the volume equation. So the volume equation is, we multiply those three to get the volume. So the length times width times height. When you write in algebra, we just write them together. That means the multiplication. So we are not going to write like L times W times H. We don't write it like that. We just write the three together. That means it's a multiplication. Also, there's another formula. And if you look at the base area, so we can like exaggerate the base. So so that's the base. So in the and then so if you say this is the base, so if you say this is the base area, so we're gonna call it A, base area. If you're the base area, if you multiply the base area by the height, you also get the volume. So that's another formula. So it is A times the height. You multiply the base area times height. That's another formula. And then if you look at the surface area, so surface area, what we can do is, what happened, you can see there are two similar sides every time. So there's a one side on this side, and there's a similar side on the other side, like that. So there are two sides always. There's one from the top, and there's one from the bottom, and then also from two sides. So there are two equal sides. So what you can do, so it is twice, because there are two equal sides, and then to get one side, you just multiply the two numbers, two letters. So that means, so we're going to multiply the length and width to get the larger one, and then you can multiply the length and the height, and then you can multiply uh, the um, the width and the height. So that's going to give you the surface area of a rectangular prism. So let's look at the next one. So next we have a sphere. So let's make it a little bit more 3D. So if you draw a few lines like that, you can make it like more 3D. And then what information we need is just the radius. So we mark the radius. Then once you know the radius, and we can write the volume equation. So this is something you need to remember. This volume equation we normally derive in calculus 3 classes. So it is 4/3 pi r cube. And also I'm going to discuss this in a different way without using the calculus argument. I will show that in a different video. So we can do it without using calculus argument. Okay, and then the surface area, this also you remember, surface area is kind of interesting. It is 4 times the area of a circle. It's kind of interesting. There's a 4 times the area of circle. So that is the surface area of a sphere. So let's look at the next one. Next, we have a cylinder. So for a cylinder, we need two information. One is the radius. We need the base radius, and then we also need the height. So if you know those two information, and this also the same, and then we can write the volume first. So volume is not that difficult. First, we're gonna find the area of the base. So that means volume is simply area times the height. Area of the base is pi r squared times the height. So that is the volume equation. And what is surface area? So surface area, there are two types of surface. One is a circular surface. So which is you can see this one is 2 pi r, 2 pi r, that's the perimeter. And then what we can do, we're going to multiply by that by height. So that you're going to get the surface area, circular one, 2 pi r h. And then you also have the top and the bottom bases. So you have two bases. You have one base there and the top. So that means you're going to get two circles. So it's a 2 pi r squared. So that is the surface area of a cylinder. These are what we normally call right circular cylinder, because there are different types of cylinders. So we normally call this right circular, because the base is circular cylinder. So that's the actual name, right circular cylinder. Okay, so let's look at the next one. Next one is a cone. Next, we have a cone. So let's exaggerate the base. So what we need is the radius r, and then to find the height. So in the height here, what we do, we drop the perpendicular onto the base. So let's say this length is h, and then what we can do is using the area times height formula, we can actually find the volume. So what we can do is, so you can show that this volume is actually 1/3 of the corresponding cylinder. So for the corresponding cylinder, if you say the base area is A, so this is A times H. The base area is simply pi r square, that's the base area, times H. So that is the volume of a cone, and then you can see that 1/3 appears every time. So it's, for this kind of geometry, you can show that it should be 1/3 of the corresponding cylinder. And the surface area, so for the surface area, there are two types of surface area. One is the lateral surface area. So for the lateral one, we're going to take this length is L, this is the lateral length, and then it is simply going to be pi r L. So that's the lateral surface area, plus the base is just a circle, so it is pi r squared. So so this is what we call the lateral surface area. Lateral surface area, this is the base. And if you want, you can simplify this one. You can pull pi r out, so then you're going to get r plus L. So that's the formula for the surface area of a cone. So let's look at the next one. Now using the Pythagorean identity, you can write L as L equal um, r squared plus h squared square root. So if you plug in that, then you can write this one as pi r plus L equal r squared plus h squared square root. So that is the surface area formula for the cone. So let's look at the last one, which is, we have a pyramid. Pyramid has a square base. So we have pyramid with the square base, and then what we can do, we're gonna use the area times height formula. So that means we need the height. So what we do, we drop the perpendicular on the base. That's the perpendicular on the base, and then which is at 90 degree. So what we need is the height of, so length of that one, and then also base, which is A and A, so the base. So that means we can find the volume is again 1/3 of the corresponding rectangular prism. So it's 1/3 and the base area is a squared. The height is h. So it's 1/3 a squared h. So that's the volume of the pyramid. And if you need the surface area, what we're gonna do is we're gonna find this slant length. So we can call this L as before in the cone case. So we're gonna call this is N. That's a slant L. And then we can simplify the four triangles around, and then at the base. So that means the surface area. So you can write as a squared. That's the base, and then we have four of the triangles. One each triangle has half, and then you can say is a times L. So that's the area of one of the rectangles, one of the triangles, and then we can substitute for that. So you're gonna when you substitute, you get a squared plus. So this is 2a times the slant L. And again, if you use a Pythagorean identity, actually you can find the slant L. How much is that using this triangle? Because this length is a over 2. This is a by 2. So that means for the Pythagorean identity, you can write L. So that means if you find L, you can write this one as a squared plus 2a. So L is simply, you can say h squared plus a squared over 4. So that is the surface area of a pyramid. But we need is a volume formula. So that's what we mostly need. Okay, so when we have a last one, uh, let's look at this hollow cylinder. Hollow cylinder. So we have a cylinder, and then there's a hole in it. So inside, like that, and then also okay. So that's a hollow cylinder. So what information we need? So there are two radii. So one is the internal radius, smaller one. So we can put small r, and then we have outer radius. There are two radius, and then if you say this length is height h, or you can say h or L, and then what we can do is we can simplify this area. This area is easy to find. This area is the difference between the large area, larger circle and a smaller circle, and then multiply by the height. So that means we can simplify the volume equation. So it is going to be pi. So you're going to be large R squared minus small r squared. So that's going to be the surface area A. Is going to be A, and then times height is h. So that is the volume of the hollow cylinder. Yeah, so these are the common ones that you need to remember as a student in the college. Thank you.